Welcome to Balaya Maths. Learn every step. Let us solve one more problem on finding of eigenvalues and eigenvectors of a matrix. Here is the problem. Find the eigenvalues and eigenvectors of the matrix -2, 2, -3, 2, 1, -6, -1, -2, 0. First of all, we have to write the characteristic equation of this matrix, which is that A minus lambda I is equal to 0. Let us say this is matrix A. That A minus lambda I is equal to 0. That means you need to subtract lambda from the diagonal. That means -2 minus lambda, 2 minus 3. 2, 1 minus lambda, -6. -1, -2 minus lambda. Determinant is equal to 0. Let us expand this determinant. Twice -2 minus lambda into. Directly I am multiplying with minus lambda with this one. That means the lambda square minus lambda. 2 6 are 12. Minus 12. Minus 2 into -2 lambda minus 6. -2 lambda minus 6. Minus 3 into, remove this first row and last column, which is -4 plus 1 minus lambda. -4 plus 1 minus lambda equal to 0. That implies -2 lambda square, -2 lambda square, -2 into minus lambda, plus 2 lambda, plus 2 lambda, plus 24. And minus lambda cube, plus lambda square, and plus 12 lambda. -2 into -2 lambda, plus 4 lambda, plus 4 lambda, plus 12. -4 plus 1, -3, -3 into -3, plus 9, plus 3 lambda, equal to 0. That implies I am writing with higher powers, that means minus lambda cube, -2 lambda square plus lambda square, which is minus lambda square, and lambdas 2 lambda, 12 lambda, 14 lambda, 18 lambda, 21 lambda, plus 21 lambda. And constants 24 plus 12 plus 9, 24, 12 is 36, 36, 45. Equal to 0. On multiplying with minus, this will becomes lambda cube plus lambda square minus 21 lambda minus 45 equal to 0. To find the roots of this cubic equation, you need to go for Harness method or synthetic division, which is 1, 1 minus 21, 1, 1 minus 21 and minus 45. You need to put 0 here and you need to obtain 0 as remainder. So let me start with -3. Actually you need to start with 1, 2, 3 likewise, but here I am directly taking -3. So 1 plus 0, 1, 1 into -3, -3 plus 1, -2, 6, which is -15, and 53 is 45 plus 1, which is 0. That means lambda plus 3 is one factor. Lambda plus 3 into lambda square -2 lambda minus 15 is equal to 0. 5 3s are 15. That means this can be written as lambda plus 3 into lambda square minus 5 lambda plus 3 lambda minus 15 equal to 0. That implies lambda plus 3 into, take lambda as common from these two terms, which is lambda into lambda minus 5, and take plus 3 as common from these two, which is lambda minus 5 again, is equal to 0. That implies lambda plus 3 into lambda minus 5 is common in both the terms, so lambda minus 5 into lambda plus 3 equal to 0. That implies the value of lambda is -3, -3, 5. So the eigenvalues of the matrix are -3, -3, 5. Now you need to find the eigenvectors corresponding to the eigenvalues -3, -3, 5. So let me start to find the eigenvectors of each eigenvalue. Let x is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to -3. Let x is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda equal to -3. That is Ax is equal to lambda x, which means A minus lambda I into x is equal to 0. You need to subtract lambda from the diagonal, which is minus 3. That means minus to minus plus 3. You need to add 3 to the diagonal. Then this becomes minus 2 plus 3. 1, 2, minus 3. 2, 1 plus 3. 4, minus 6. Minus 1, minus 2, 3. Into x1, x2, x3 equal to 0, 0, 0. You can solve this homogeneous system of equations. So let us reduce this one into echelon form. How? R2 tends to R2 minus 2R1, R3 tends to R3 plus R1. Then this becomes 1, 2, minus 3. This is 0, 0, 0 and this is also 0, 0, 0 into x1, x2, x3 equal to 0, 0, 0. The rank of this matrix is 1, which is in echelon form, and the rank is 1. Therefore, rank of A is equal to 1 but less than 3, which are the number of unknowns. So rank A less than number of unknowns means the system has infinitely many solutions. The system has infinite number of solutions, and n minus r, that is equal to 3 minus 1, is equal to 2 linearly independent solutions. How can you find those solutions? By writing this equation, which is x1 plus 2x2 minus 3x3 equal to 0. As there are 2 linearly independent solutions, you need to take 2 variables as constants. Let me take x2 as k1 and x3 as k2. Let x2 is equal to k1 and x3 is equal to k2. Then x1 becomes 3k2 minus 2k1. Therefore, the eigenvectors can be written as something into k1 plus something into k2. That something is nothing but k1 coefficient in x1, which is minus 2, and in x2 is 1, and in x3 there is nothing, so it is 0. And coming to the k2 coefficient in x1, which is 3, and in x2 there is nothing, which is 0, and in x3 it is 1. This is one eigenvector and this is another eigenvector corresponding to the eigenvalue minus 3, which is repeated twice. So the eigenvectors are, therefore, x1 is eigenvector which is minus 2, 1, 0, and x2 is one another eigenvector which is 3, 0, 1. Now you need to find the eigenvector corresponding to the eigenvalue lambda is equal to 5. Let x is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to 5. That is Ax is equal to lambda x. That implies A minus lambda into x equal to 0. That means you need to subtract 5 from the diagonal of the matrix and multiply with the x, which is equal to 0. That means minus 2 minus 5, minus 7, 2, minus 3. And 2, 1 minus 5, minus 4, minus 6. And minus 1, minus 2, 0, minus 5, minus 5. Into x1, x2, x3 equal to 0, 0, 0. Now let us reduce this one into echelon form. R2 tends to 7R2 plus 2R1 and R3 tends to 7R3 minus R1. Then this becomes no change in the first row. Minus 7, 2, minus 3. So this is 7R2 plus 2R1. 14 minus 14. 0 minus 28 plus 4. Minus 24. And 7 6 are minus 42 minus 6. Minus 48. And minus 7 plus 7. 0. 14 minus 2. Minus 16. Minus 35 plus 3. Minus 32. Now use this element and make this one as 0. Here it is clear. If you divide it with minus 16, then this becomes 1, 2. And if you divide this one with minus 24, this is also 1, 2. So this row will becomes easily 0. R3 tends to 24 R3 minus 16 R2. Then this becomes 7 minus 7 2 minus 3 0 minus 24 minus 48 0 0 0 into x1 x2 x3 equal to 0 0 0. Similarly into x1 x2 x3 equal to 0 0 0 again. Now the rank is 2. Therefore, rank of A is equal to 2 less than 3, which are number of unknowns. The system has infinitely many solutions and n minus r is equal to 3 minus 2, one linearly independent solution. How can you find that solution? By writing the equations, which are minus 7x1 plus 2x2 minus 3x3 equal to 0 and x2 plus 2x3 equal to 0. As there is one linearly independent solution, you need to take one variable as constant. Let me take x3 as k. That implies x2 is minus 2k. And by substituting these things in this one, 7x1 is equal to 3x3. x3 is k, so 3k. And minus 2x2, which is minus into minus plus 4k, which is 7k. So x1 becomes, that implies x1 becomes k. So x1 is k, x2 is minus 2k, x3 is k. Therefore, the eigenvector x3 is something into k, that something is x1 quotient 1, x2 quotient minus 2 and x3 quotient 1. 1 minus 2, 1 is the eigenvector corresponding to the eigenvalue lambda is equal to 5. I request all of you, please like, share, comment and subscribe my channel Balaya Math Lectures. Thank you.